Okay, so welcome to part 2 of my demo video on Lab 10135. I have done all of the stuff in part 1, up to and including connectivity verification. Now what I'm going to do is dive in on OSPF implementation. So, I've got to punch in my passwords. Okay. So that means we need to look at the next section of this. The simplest OSPF implementation is a single router. A single area implementation. So I've enabled these things. I'm going to create a routing process. I'm going to give it the routing process an ID so that no matter what state my physical networks are in, the routing process will know its identity. I don't have to worry about reloading the router or restarting the process or any of that stuff. So, boom. Notice there's no there's no IP unicast routing IPv6 unicast routing command because this is strictly v4. And another thing I want you to note, I am, of course, as always, I'm declaring the networks that are connected. And before I do that, let me do this: show IP route connected. Boom. I can see 12.0/30, 23.0/30. Now, I said I'm declaring the routes that are connected. In the case of router 2, to show IP route connected, there is an exception to that rule. So on router 1, I declared the 1.0 network, the 1.0/24, 12.0/30, 13.0/30. On router 2, I'm declaring 12.0/32 and /30 and 23.0/32. Notice I am not declaring this network connected to the loopback because I'm going to handle that differently. Okay, and notice I've got my first neighbor adjacency up as well. So now let's move on to router 3. And again, I'm going to do show IP routes con, route connected. So I need 3 and 13 and 23. Because I'm declaring 13 and 23 on a router which is at layer 2 and layer 3 adjacent to other routers that also are using that same network, that's how the adjacency will form. That's the channel, the communication channel through which all of those hello packets and database descriptions, the DBD packets, and your LSAs and your LSUs and all of it is flowing down these channels that I'm creating now. So I'm going to do this, copy, paste, and I need to give this probably a few minutes. There, I've got 2, I've got 1. So what I can check for now, the first thing we want to check for is our, you're going to do show IP OSPF neighbor and show IP OSPF route. We want to make sure that the neighbor adjacencies exist. So I'm going to type end to get all the way out of config mode so I don't have to use the do command. Show IP OSPF neighbor. And I can see, hold on. Okay, so I'm on router 2 now. I'm doing show IP route OSPF. So I have a route to 1, I have a route to 3. Notice that from the perspective of router 2, there are actually 2 routes into this 13 network. One of them via 12 and one of them via 23. That's what I look for when I do show IP route OSPF. So there's that. I can tell that my routes, let's do show IP route. I can tell that my routes are my routers are fully converged. This is what I expect to see. A route to 1, a route to 3, and all the networks in between. Let's see. So the next thing we're going to do, and of course the next thing we really want to do, now we really have to test end-to-end connectivity. So what I'm going to do from PCA is actually ping PCC, ping 192.168.3.3. And it can go all the way through. If I had tried this before, it would have failed, because I could have pinged the far side of the 12 network from here, and the far side of the 20 of the 13 network here, but I could not have pinged into the 23 because this router, without static routes or routing information, can only handle routes into networks that it is connected to, of which it is a part, shall we say. So my pings work. Now let's change the OSPF metrics. What we're going to do here in changing the OSPF metrics is to make sure that we are costing this in the way that we want to cost it. So we don't make the mistake of treating a slow serial line as equivalent to a fast serial line and thus miscalculate, shall we say, the SPF tree. The goal of the shortest path first algorithm is to find the least cost route from point A to point B on the basis of exit interface cost. So if you have two serial lines and one of them is running at half the speed of the others, and you don't tell OSPF anything about that fact, you're going to have problems. It may not know, it won't know to prefer the faster serial line to the slower one. So what we're going to do, we're actually going to do set the bandwidth on all our serial interfaces to 128 kilobits per second. We're going to do this first by doing show IP OSPF interface brief. Actually, this works in, now we're actually not going to do this, not in Packet Tracer anyway, because we can't do this in Packet Tracer. What I can do, however, is do show IP interface, the OSPF interface serial 0, 0, 0. Oh, and it would help if I spelled OSPF correctly, wouldn't it? Okay, so I can see, let's see, my cost is 64. I cannot do show IP interface brief because, okay, and it's going to want specifics, serial 0. This is just one of those things that Packet Tracer doesn't configure well. So we see a cost of 64 kilobits per second. Actually, let's do show interface. Okay, so my bandwidth, my physical bandwidth is 1.544 megabits per second, or 1544 kilobits per second. What we're going to do is change that. And they're also doing HDLC encapsulation. Layer 2 encapsulation is something you'll worry about more in the first couple of chapters of connecting networks. So let's actually start right here. Config T, int serial, and actually I'm going to copy and paste. Let's make it easy on this. So I'm going to do this. Copy. Paste. Boom. Now, let's do the bandwidth command again. And let's do show IP interface brief again. And I can see its cost has jumped. Notice the cost was 64. On the basis of a bandwidth of 154 1544 kilobits per second. I set my bandwidth down to 128 kilobits per second, and now my cost is 781. I'm going to do the same thing on all three routers. Oh, okay. Got to config T first. Okay. And let's do 3. Now, I could probably have technically done this directly from router mode. The int serial 000 command would have moved me directly to interface mode. So let's do. Okay, and I can see my neighbors again. I cannot see my costs again. So we've done that. The next thing I want to do, we're to use so we've used the bandwidth command. We've done that. Our costs have skyrocketed from 64 to 5. And actually, let's look at that. Well, the best way to see this now, because we can't use the interface brief command, let's look at the routing table itself. Notice my routing table. Notice how high this is. Actually, I did this one before. Let's for a more valid comparison. This is what it was before I made all my changes. 128. I did the same kind of thing on router 3 now, and we're talking about we go from a cost of 128. That's of course 64 plus times 2 to 1562. So an order of magnitudes difference. So the next thing we want to do is auto cost reference bandwidth on all three routers. So T. So what I'll do here is my auto cost reference bandwidth. What this will do, and I actually have to do this on all three of them, is set my reference bandwidth so that it will treat my gigabit line as normal. By default, it treats a fast Ethernet as the standard. So let's look at that routing table again, shall we? Do show IP route SPF. Okay, and now my reference bandwidth has changed a little bit more. My reference bandwidth is, for the 3.0 network, is 600. My metrics to get into the 23 network is 1294. Actually, let me go back on here. Let me do this again. Aha, that's why. I was doing those show commands in. So my reference bandwidth has come down. My metrics costs have been recalculated a little bit on the basis of gigabit speed. Now, the last thing you want to do, we're going to cost one of these routes. The S001 on router 1, we're going to give it a cost of 1600. Now, and let's do that again. Okay, so again, our costs are changing on the basis of how we get into this network over here. Now, there's one final piece of this puzzle. I'm about out of time, but the good news is I can configure a default route very quickly on router 2 by doing router 2. Where did it go? Ah, I put this on the wrong place. Good to know. Oh, hold on, I'll pause this. Okay. Default information originate, and now let's do show IP. So finally, I created a default route with default information originate.